Welcome to the project demonstration of speed control of AC induction motor using Arduino UNO. So here the main application of this project is we are going to control the speed of this single phase AC induction motor by using Arduino UNO based on the selection switches. So we are controlling the speed in 5 levels, that is a 0 to 4. So 0 is the off, 4 is the maximum speed. So when we select these switches, our Arduino UNO will control the on time to this motor with help of triac board. And to control the triac board signal, the on time has to be started from the positive waveform, and the positive waveform starting will be detected by this zero crossing detector. So whenever you want to control the AC PWM signal, means AC voltage controlling purpose, then we should know the positive waveform starting time. Means whenever the positive waveform starts, our Arduino UNO will get the trigger pulse, and from there we can control the timing signal to the positive waveform by using the triac board. Means as we know that we are using 230 volts, 50 hertz of frequency we are using. So 50 hertz frequency nothing but 50 on pulses and 50 off pulses. So each pulse consists of 20 milliseconds. In that 10 milliseconds is a on signal, 10 milliseconds is a negative waveform. Nothing but negative current is 10 millisecond, positive current is 10 millisecond. So we need to control the positive current signal. Then only we can control the output voltage, so that we can control the speed of this AC induction motor. There we are going to divide that in 5 levels. So 0, 2 milliseconds, 4 milliseconds, sorry, 2.5 milliseconds, and next 5 milliseconds, and 7.5 milliseconds, and 10 milliseconds. So in that manner we are going to dividing the ratio to 0 to 100% in 5 levels, 0 to 25, 50, 75 and 100%. So the on time also will be controlled to this triac board based on the selection switch, and the speed level which we have selected is displayed on the LCD screen. So coming to the major components, so this is selection switch, LCD display. In the selection switch are interfaced to the A0 to A4, LCD at pin number 3 to pin number 8, zero crossing detector to detect the positive waveform starting signal time. It was the other was interfaced to the pin number 2, and triac board interfaced to the pin number 9. And this is the regulated power supply board. So it's totally part of regulated power supply section. So it has the 4 stages. First one is a transformation. So as we are putting the 230 volts AC inputs, and parallelly we are distributing that to the transformer as well as to the motor through the triac board. So as you can see that, okay, connected to the motor through the triac board in series. So the transformer will step down the 230 volts AC to 12 volts of AC, that is input to this board, and it has again here 3 stages remaining. So one is the rectification to convert the AC to pulsating DC, filtration to remove the pulses, provide as a constant of 12 volts DC, and regulator which will take 12 volts DC and provide as a 5 volts DC output, that is the operating voltage to our microcontroller. Once we provide the 5 volts input to that, the system starting reading input from this switches. And coming to the zero crossing detector, will get AC 12 volts. So there you can see so this is the 12 volt AC which is directly parallel to the transformer output. So means when the 12 volts AC is input to this, the rectifier will rectify that to pulsating DC. So whenever the pulse starts, the transistor will be getting on and off. Means here the sine pulse will be converted to the square pulse with help of this transistor, and the resistor's purpose is potential divider purpose, because 12 volts AC we are providing, the 12 volts pulsating DC means the pulses has a 12 volts, but the microcontroller can understand up to 5 volts only. For the purpose we are using a potential divider. So after that the voltage will be divided to below 5 volts. So then the transistor will be controlled based on the on signal of pulse waveform starts. So right, so that's the purpose of the zero crossing detector and the potential divider in the zero crossing detector. So let us see the demonstration. When we on this, so it will comes to 0 initially, so motor controlling, and the speed is 0 as the motor status is stop only. So when we select the 1, so motor status is run, and it rotates at 25% speed only. It's a full speed. Again directly we can off, stops, full speed, and we can decrease the speed gradually, 75%, 50%, off. So in this manner we can control the speed of single phase AC induction motor.